So as part of some of our biochemistry support, this is probably more chemistry than bio, I suppose, strictly, truthfully speaking, we're going to look at the reaction of glucose. We made in a no expense spared, it got a 20% solution of glucose. It needs to be acidified with some dilute sulfuric acid, and then our indicator, our other reagent, is potassium manganate, and we're going to look at how the reaction occurs, the time reaction takes place with different concentrations. So how are we going to crack on and do that? Well, in some good old bucket chemistry, we could be having beakers full of it, of different concentrations of our reagents, and I'll talk more about the combinations of those in a second. Or we could be slightly more frugal and have test tubes of the reagents being involved in the reaction. But let's just see if we can be even more frugal than that. And I'm not going to do them all, but just one as an example. Because here's our freestanding colorimeter, which we'll have connected up, not right at this point, obviously, but slightly further down the line. And not quite on microscale chemistry yet, but we've got our cuvettes. So what's the phrase? Failure to prepare is preparing to fail. Well, let's just see where we fall down on that statement. The solutions we have and the volumes of them clearly will be dependent upon what type of container you're going to use. You just need to check the volume of those things before you start overflowing. And I think about 3 mil is about all those will contain. I'll talk more about where the levels have to be for the colorimeter to work in a wee while. And if you're marking things up, just make sure that you're not marking them over the clear part where the colorimeter is going to work. So in a moment, I'm going to probably make a complete hand-fisted addition of the 3 reagents into the cuvette, and then we're going to time for the indicator, for the dye, to decolorize.